All right. But word problems we're going to focus on today. So we're still on 5C point, what, I can't talk. We're on, 5 part 2, number 13, right? So it says here, if you have deposited $1,000 in an account that pays 6.5% interest, compounded continuously, you can find the balance of your account using the formula A of t equals 1,000 e to the 0.065 t. This is a very commonly used formula, okay? So this formula is very, very common. Without it, it's written in the format of A equals your principal times E to the RT. If you become a business major or any of those, or accounting or any of those, you will see this formula again. Okay, P stands for your principal, your original amount. R stands for your rate as a decimal. So it says, and T is for time. Yep. And so it says, use this formula to find the time required for a balance in your account to double. So currently you're at 1,000. To double means that it's going to be at 2,000. So you're looking for how long will it take you to get $2,000 following 1,000 e to the 0.065 t. Okay. And we're going to use the calculator to do this, but before we do that, we want to get t by itself. So the first thing you're going to do is undo your multiplication. So to undo multiplication, we're going to divide. And we're left with 2 equals e 0.065t. Okay. Now we want to undo our e. How do I undo e? Natural log. We're going to take the natural log of both sides. That's going to cancel that out. And we're left with natural log of 2 equals 0.065t. T is almost by itself. What do I do to get t by itself? Divide. So now we're going to find out what t is approximately. So we go to our handy dandy calculator and we're going to type in the natural log of 0.065. Natural log of 2 divided by 0.0625. Turning on Sylvie. She's been working today. Natural log of 2 divided by 0.065. Uh-oh. What did I do? Oh, weirdo. Delete. My keys are sticky. All right, so we get about 2. We're around to the nearest 3 decimal places. So it would take about 10 and 4 years for me to double at the current interest rate. Now, was that terrible? Applying a formula and solving. Okay. All right, so it says find A of t, mean inverse of t. So this -1 means I'm looking for the inverse. When you're looking for the inverse, that means instead of it being in terms of time, it's going to be in terms of your amount. So you can, to find that, all we're going to do is switch our A and T, right? And then solve for A. Do you remember doing that? Find the inverse. You're switching your input with your output. So it's going to look like this. So now we have T equals 1,000 e to the 0.065 A. And we're going to apply the same steps that we did here to double it, but just now for any amount. Does that make sense? So we're still going to divide by 1,000, right? So we're now left with T over 1,000 equals e to the 0.065 A. We're still going to take the natural log. That's exactly what we did here, right? They cancel out. So we're now left with natural log of T divided by 1,000 equals 0.065 T. A. Thank you. Good call. Good call. And then now we're going to divide all of that by 0.065. Now, we can clean this up a little bit. So, A inverse of t equals, if I have anything divided by 1,000, that's the same thing as saying that I'm going to, anyone else? Multiply by what? 0.001. So 1,000th is the same thing as 0.001, right? Do we agree with that? And then divided by 0.065. So that is my inverse. Okay. Why would I want to use the inverse instead? Anyone? What am I now saying you're giving me? So it's now you're looking for, I have this amount, what is going to be my time, right? So it's what a balance is years. So it's going to be our time in years, right? A inverse of t is the years. And let me know if this is not grammatically correct, guys. When a balance and account is known or reaches balance, when a balance in the account is reached. No, balance in account is known. Blame it on the date, Will, okay? If I did not make grammatical sense. So now, if I know my balance, what's really I'm plugging in is T now is your amount. So we would plug in, like, for example, 2,000. We would have plugged in 2,000 and found the amount. So, for example, if I told you I want to save $5,000, you could use the inverse to say, okay, it's going to take you this amount of time to save $5,000. With my calculator. So if I wanted to save $5,000, I would be using natural log of 0.001 times 5,000. Okay, cool. I'll go over there. Oh, okay. Just want to keep me on my toes. Divided by 0.065. So it would take me 24.6761 years to save $5,000 at this current rate that it's going. Okay. All right. It's going to take me a minute to get to $5,000. It's going to take a little bit of time. Just a little bit. Okay. Just a little bit. All right. Okay. But yes, so that's how solving and using the formula. So what if I wanted to graph and compare the inverse? So with the inverse now, that means that time is your y-axis, right? And then your amount in dollars, dollar bills, y'all, is your x-axis. Okay, so we discovered that in the beginning, we were at 1,000. And then we went, how long did it take us to get to 2,000? 10 and something, right? 10 and something. Let's see, is that a good? It took us some 10 and some time. So it's going like this. Guys, my 10 is way off. It says, look. I tried, guys. I tried. Just got a lot of myself. There you go. It's close enough, right? It's concave down. Because it's a log. The inverse is a log. Right? Natural log of 0.001. Yeah. All right. And then it says here, using this, explain the meaning if I ask you for the inverse of 1500, A inverse of 1500. What does that mean? Ooh, yeah. What am I asking for? What does 1500 represent? The amount. So I'm asking how long would it take me to get to 1500? So how long would it take me?
6.5 years.
Yeah, somewhere in there, right? So if we follow our little trajectory here, and then you can do the math check. So I'm like here.
Oh,
Here, guys.
why is it so?
Okay, I'm a little low.
You did it like footsteps.
A little low.
Or 6.
Yeah. So if you did it in the calculator, you should have gotten like 6.24, 6.2. So we're like 6.24 years. So the account balance will reach $1,500 in about 6.25 of a year. 40 years. That's not a 4. That's a 4. All right. So this would be an example of a simple FRQ where you have to explain what it means, find the inverse, apply the inverse, graph the inverse. I feel like that's a doable situation for the most part. Yeah. All right. Next possibility of what it could look like is filling in a table. So here, if you have e to the 2x equals 60, and you're going to figure out first, what is x, right? You got to figure out what is the value of x in order to keep it going with this. In order to find the value of x, what do we need to do first? Huh? Natural log. Perfect. So we take the natural log of e to the 2x, and what we do to one side, we do to the other. These cancel out, and we're left with 2x equals the natural log of 60. What do I need to do to get x by itself? Divide. So x is approximately whatever that is. Go to our calculator. Oh, I'm really tired of not being able to breathe properly. It is not okay. Yeah, we get 2.047. $2.047. All right, and then at this point now, I just want you to be able to just fill in and find the values of all these x's. And if I'm just finding the value of x, what does that mean I'm doing? I'm just substituting in. Does that make sense?
Yeah.
Can we confidently substitute values in?
Yep.
I think you can too. I personally believe you can. I believe in you. Sorry. Good day. All is not till Monday.